Welcome to another episode of Dealing with Construction Errors. The construction sequence starting from land acquisition, surveying, fencing, ground clearance, then excavating, formwork erection, then concreting as per the blueprint. To be noted, there are many processes are involved in between such as procurement, material testing, statutory regulatory approvals, etc., which we are not covering here. We are exploring the critical errors that can occur that can impact both cost and scheduling in construction that result bad quality cost recurrently. The aim is to reduce this error to prevent the bad quality cost. We have already covered the formworks and excavation related errors in our previous episodes. Now let's shift our focus to concrete, a fundamental component in construction. Before addressing construction errors related to concrete, it is important to first understand the role of rebar. Please note that we are focusing on rebar erection errors and will be bypassing preliminary processes such as pad, BBS development and on-delivery inspection, etc. In this video, we will explore the problem areas of rebar. As per IS 456, steel bars are wires used for reinforcing concrete structure. As per ISTM A706, deformed steel bars for concrete reinforcement. Okay, let me put it in simple way. It's a steel bar used to reinforce and strengthen concrete structure. It provides tensile strength to concrete, which is inherently weak in tension. So, it improves the structural integrity of the concrete. While rebar quality testing involves several processes, it is crucial for the quality engineer to ensure compliance with standards such as IS 432 and IS 2502 and to verify that the rebar is tested and approved for use. Bar bending schedule. A properly prepared bar bending schedule is essential. Errors in this schedule can lead to improper rebar placement and alignment, compromising structural integrity. Ensure that the rebar yard maintains a revision history of the bar bending schedules so that the construction team works with the most current revision. Also, it is to be ensured the rebar yard receives the latest IFC. Here we can observe the improper stacking of rebar. Rebars must be stacked to prevent exposure to moisture. Incorrect stacking can lead to corrosion, reducing the strength of the rebar and subsequently the concrete structure. Improper stacking of rebar can lead to issues with corrosion if not managed correctly. It's always recommended to stack rebar on a cement bed and enclose it within a roofed structure to prevent direct contact with moisture. This setup helps mitigate corrosion risk. In situations where such infrastructure is not feasible, avoid bulk purchases and long-term storage. However, cost-saving measures always lead the contractors to opt for bulk procurement due to better price negotiations with manufacturers. When bulk purchasing is necessary, we are not given with enough infrastructure. Stack the rebar on a sufficiently elevated cement platform to ensure the rainwater or other moisture does not accumulate underneath. Continuous monitoring is essential to maintain the condition of the rebar. Improper galvanization. Rebar should be adequately galvanized to prevent rusting. Inadequate galvanization can lead to premature deterioration of the rebar. According to ASTM A767, there is a specification for galvanization, the zinc-coated galvanized steel bars for concrete reinforcement. Galvanization methods are detailed, including the application of protective zinc coatings. Although many contracts may not mandate galvanization as a cost-cutting process, designers often include it as a specific requirement for enhanced durability. Improper galvanization make the purposes defeated. Correct spacing of rebar is crucial for load distribution and structural stability. Incorrect spacing can create weak points within the concrete, potentially leading to structural failures. Insufficient cover. Meeting the minimum requirements is crucial as inferior quality cover can lead to damage of the cover during erection, which defeats its purpose. We need to remember the placing of covers ensures adequate spacing so that the concrete can entirely spread the structure and properly cover the reinforcement. Use of corroded or contaminated rebar. Rebar must be free from corrosion and contamination before use. Using corroded or contaminated rebar can undermine the strength and durability of the concrete structure. Inadequate bar size. Rebar size must meet design specifications. Using bars that are too small can impact the load bearing capacity and overall safety of the construction. Poor lapping. Rebar lapping must comply with specified standards to ensure proper load transfer between bars. Poor lapping can create weak joints and diminish structural strength. Misalignment and incorrect bending. Rebar must be correctly aligned and bent according to design specifications. Misalignment and incorrect bending can compromise load bearing capacity and overall structural integrity. Poor cutting and handling. Poor workmanship lead to bad quality cost. Rebar should be cut and handled with care to avoid damage. Poor practices can result in rebar that does not fit properly or has compromised strength. According to IS 2502, the standard for bending and fixing of bars for concrete reinforcement, bar bending is an operation which requires adequate supervision, skilled workmanship, and efficient equipment. And any attempt to carry out the work with unskilled labor and inefficient tools will undoubtedly result in unsatisfactory work. Thank you for joining this detailed review of rebar related construction errors. For more information on maintaining construction quality and preventing errors, please visit our website.